Okay, so before we begin, let's talk about mixed numbers really quick. Okay, I have one whole, and then I have 3/5. And I want to show that this is a number. How would I write this mixed number? I have one whole and I have 3/5. How would I write this mixed number? Michaela?
You would write one like the one whole,
I would write 1 for the whole.
and then next to it you would write 3/5 like you normally do with fractions.
And then I would write 3/5 right next to it to show my fraction. And all together, how do we say this mixed number, Michaela?
1 and 3/5.
1 and 3/5. How could I write this as an equation? Victoria.
You could do
There's a couple ways I could do it. 1,
2/5.
is that an equation?
Oh, 1 plus
Let's do unit fractions. Well, no. How can I write this as an equation using unit fractions?
2/5. 1 plus 2/5.
Is 2/5 a unit fraction?
No, 1
1 plus 1/5
plus 1/5
plus 1/5
plus 1/5
plus 1/5
equals
equals
1,
1
and 3.
and 3/5. Good. Now, so we've written it as the sum of the whole numbers and the unit fractions. 1 plus 1/5 plus 1/5 plus 1/5 equals 1 and 3/5. What's another way I could decompose this? Colin.
1
1
plus
plus
2/5
2/5
plus 1/5.
plus 1/5. 1 whole plus 2/5 plus 1/5 equals
1 and 3/5.
1 and 3/5. Now there's one more way I could write this. Carla?
Another way that we can write it is 1
1
plus
plus please make sure you have an answer before you raise your hand. Anybody else? This is 80?
1 plus 3/5
1 plus 3/5
equals
equals
1 and 3/5.
1 and 3/5. Good. So those are different ways we can decompose. If we had more wholes, we would just add more ones to the beginning. That's all we would do. Okay, so today we're going to be working with mixed numbers, but we're going to be working on adding mixed numbers. That means both of our add-ins are going to be a mixed number. So, read the sentences under the title. Kingston.
Mixed numbers are numbers, like a whole number and a fraction. We can decompose mixed numbers to add them. Use the associative property to break the whole numbers and like fractions together.
So that's what we're going to be doing today. We're going to be breaking down our mixed numbers into the sums of the wholes and the unit fractions. Then we're going to be using the associative property. Remember, that's the property that had the parentheses, the groups, to put all the whole numbers in one group and all of the like unit fractions in one group, or just the like fractions. Sometimes we'll be doing unit fractions, sometimes we'll be just doing the like fractions. So we'll see what that means in example 1. So everybody, finger or pencil on example 1. When I see everybody's finger or pencil, scoot your chair and use your self-discipline to keep your chair scooted in. Everybody. Read in your head while I read out loud. Madison made a fruit salad. So I'm imagining a girl cutting up fruit, putting it all together in a bowl. She used 3 1/4 cups of strawberries. So I'm imagining 3 measuring cups that are full. And then 1 that is only 1/4 full of strawberries. And 2 1/4 cups of blueberries. So now I'm imagining she's using that same measuring cup, filling it all the way twice, and then filling it 1/4 of the way once with blueberries. How many cups of how many cups of berries did Madison use all together? So remember, all together is a word that tells you to add. So we know we're taking the amount of strawberries and the amount of blueberries and putting those groups together to create a larger group. So we are adding 3 1/4 cups of strawberries plus 2 1/4 cups of blueberries to figure out how many cups of berries she had in all. Yes, Cullen.
My book put all together in 2 words.
Oh, that's weird. I don't know. Well, but it means the same thing. So probably all of your books have it in 2 words. Yep, they do. Except for Lena's. But well, I don't know. That's weird because this is the most recent version. Whatever. Doesn't matter. Okay. So what we're going to do first is we are going to decompose each mixed number as a sum of whole numbers and unit fractions. So this. Just like what we did in lesson, I don't know, one of the last lessons in lesson 8. I don't remember. It was the second to last one. Where we took the whole number and we added 1 however many times the whole number told us to. And then we took the fraction and we added 1/4 however many times the numerator told us to. So, for 3 1/4, how many whole numbers are in 3? Class? 3. So I'm going to add 1 plus 1 plus 1 because all together that is 3. Now I'm going to decompose 1/4 into its unit fractions. Well, the numerator 1 tells me there's only 1 1/4. Because 1/4 by itself is equivalent to 1/4. Bless you. Now we're going to do the same thing with 2 1/4, and we're going to add them together. If I have 2 wholes, how many wholes do I have? How many ones do I have? If I have 2 wholes, how many ones do I have? Class? 2. 1 plus 1, because I know together that is 2.
I just turned out.
You did, okay. Now I have 1/4. The numerator of 1/4 tells me how many 1/4 do I need to add? Class? 1. So now I have my equation. But with these ones and unit fractions all over the place, it gets a little confusing. So what I'm going to do next is use the associative property to group the whole numbers together and to group the unit fractions together. So what I'm going to do is I'm going to pay close attention. I'm going to start with my first parentheses, and I'm going to point to each whole as I write it down here so I can make sure I don't put too many or too little. So 1 whole plus 1 whole plus 1 whole. I'm going to skip this unit fraction because our unit fractions and whole numbers alike. Can we put them together in the same group of like things? No. So I'm going to skip it for now and move on to the next whole number. Plus 1 plus 1. And I don't have any more whole numbers, so I'm going to go ahead and put my end parentheses. So does everybody see what I did? As I wrote my new whole number in my group of just whole numbers, I pointed to make sure that I wasn't putting too many or too little. Now, I'm going to put my plus sign, and I'm going to group my unit fractions together. So I'm going to do the same thing. I'm going to go through and point to the unit fraction as I write it. Now I have these three whole numbers. Can I put them in the same group as unit fractions? No. So I'm going to skip them, and I'm going to go to this 1/4, and I'm going to write it, and then I have two whole numbers again, which I know I can't put in the same group, and then I'm going to go and add this other unit fraction. I have none left, so I'm going to put my end or my closed parentheses. Now this is much easier to do all at once. I just add all of my whole numbers and I add my unit fractions without having to skip or anything like that. So class, 1 plus 1 plus 1 plus 1 plus 1 is 5. And then they brought down their plus 1/4 plus 1/4. You can just add these and skip all the way to the next step. 1/4 plus 1/4 is
2/4.
2/4.
2/4.
So, class, just like 1 plus 3/5 is 1 3/5, 5 plus 2/4 is 5 2/4. What do we need to do now? Are we done? Carla? No, what do we have to do?
We have to simplify.
We have to check for simplest form. 2/4 is not in simplest form because they're both even. So there's our clue. So let's give ourselves space and list the factors of 2 and 4. Who would like to help me? Lena, I saw your hand first. Do you want to list or do you want to match? List, okay? Factors of 2.
1 and 2.
1 and 2. Factors of 4.
1, 2, 4.
Common factors.
1 and 2.
Greatest common factor.
2.
So we divide the numerator and the denominator each by
2.
2. Now, I'm going to tell you what a lot of you guys are going to do, and you're going to end up getting it wrong. I'll show you right now. This is what you're going to do. This is telling me that 5 2/4 is equivalent to 1/2. Is that true? No. So what you need to do is after you have your division, you cannot forget your whole number. You have to rewrite your whole number, and then 2 divided by 2, class?
1,
4 divided by 2?
2.
Then
2.
you write 1/2. Do not forget to move your whole number. You can show the division right there, but do not forget to move that whole number. Otherwise, you're telling me that 5 2/4 is equivalent to 1/2. And if we model that, we know that is absolutely incorrect. I'm going to do it over here. I'm going to model 5 wholes. 1, 2, 3, 4, 5. I'm going to shade them because otherwise they don't exist. And then I'm going to model my 2/4. So I have the same whole broken into 4 pieces. 2 are shaded. And if you forget to rewrite the whole number, you're telling me that this is equivalent to this. And is that true at all? Do we have the same amount shaded here as here? No. So you have to make sure to move this whole number to your final answer. Do not forget to move the whole number to your final answer, otherwise you're going to be wrong because 5 2/4 is not equivalent to 1/2. 5 2/4 is equivalent to 5 1/2. So, read this last sentence and fill in the blank. Ethan. Nope, you have to read the whole sentence. The whole sentence.
So Madison used,
Louder so we can hear.
so Madison used 5 whole what?
How do we say mixed numbers? We don't have to say the word whole. We just have to say the word and between the whole number and the fraction part. So say it again. So,
So Madison used 5 cups of berries.
so Madison used 5 1/2 cups of berries. Notice how down here they modeled, and 5 + 2/4 was not 1/2, it was 5 1/2. Do not forget, please listen to me. Please do not choose to not listen to me right now. Choose to listen and follow that direction. If you choose not to listen to me and you choose to not follow that direction and you choose to tell me that 5 2/4 is equivalent to 1/2 and you choose to not show work and not list the factors in order to show how you found simplest form, that will be a whole lot of points lost. Because you are going to end up getting more points for showing work in this lesson than you will for the right answer. Because in order to know the right answer, you have to know how to get there. The most important part of math is not just knowing the right answer. It's knowing how to get to the right answer so that you can do it again. Or when you get to the next grade, you can add on to it. The how is so much more important than just the right answer because you have to repeat it. And if you don't know how, you're not going to be able to repeat the results. Okay. Helper number 1, please sanitize, erase, sanitize. Okay. There is another way that we can do this. We can either break it up into an equation using the whole numbers and the unit fractions and then using associative property to group them together, like we did in example 1. Or we can convert each fraction into mixed numbers. Each mixed number into an improper fraction, and then convert the improper fraction answer back into a mixed number. So that's what we're going to do with example 2, but we're not going to do it the way the book told us, because we're going to do it the way that I taught you. Okay? So, everybody, finger or pencil on example 2. Yes?
There's sentences on
I told you that. So we don't need to reread them. When I see everybody's finger or pencil on example 2, I will continue. Okay, read in your head while I read out loud. Find 1 1/3 plus 2 1/3. We're going to use the way where you can convert it to an improper fraction, but not using models or this right here because that's confusing. We're going to follow the steps that were on your anchor chart. So, actually in this moment, go ahead and get out the anchor chart that tells you how to convert mixed numbers and improper fractions. So, to take mixed numbers and turn them into improper fractions, first we do what? Carla.
Start with the denominator.
And what do we do with the denominator?
We multiply it with the whole number.
So not with, but by.
By the whole number.
So we're going to take, 1 1/3. We need to start with the denominator, which is 3. And we need to multiply it by the whole number, which is
1.
1. Class, 3 times 1 is? 3. Then what do we do? Cullen.
Add the numerator.
Add the numerator. What's the numerator?
The numerator is 1.
The numerator is 1. Class, 3 plus 1 is?
4.
4. That answer is the new Carla?
The new numerator.
The new numerator. So our numerator is 4. What's our denominator? Lena? 3. Why is 3 our denominator?
Because it always stays the same.
Because it always stays the same. So that means, class, 1 1/3 is equivalent to?
4
Class, 1 1/3 is equivalent to, it is right here in front of your faces, up here or on your book if you are working with me, so there should be no hesitation. 1 1/3 is equivalent to? 1 1/3 is equivalent to? 4/3. Let's do the same thing with 2 1/3. What do we do first? It's on your anchor chart. Unless you can't find it because you did not follow directions. Zari, what do we do first?
Multiply the denominator by the whole number.
We multiply the denominator by the whole number, which means we're multiplying what times what?
3 times 2.
3, our denominator, times 2, our whole number. Class, 3 times 2 is? 6. What do we
6.
do next? Same people, you have it right in front of you. There's no excuse to not raise your hand and participate. Zari just told us the first step, start with the denominator, multiply the denominator by the whole number, so we know it, because it's written right here, what to do next. Kingston, add the numerator. So what are we adding?
3 plus 3 plus 1.
Our numerator is 3 plus 3 plus 1. What is our numerator? 1. Class, 6 plus 1 is? 7.
7.
That is our what? Aaron, new numerator. What's our denominator? Colin,
3.
how do we know that?
Because our denominator stays the same.
Because our denominator stays the same. So class, 2 1/3 is equivalent to?
7/3.
7/3.
7/3. So now we're going to add these like fractions. 4/3 plus 7/3. When we're adding like fractions, what do we do first? When we add like fractions, what do we do first? We just did this lesson like 3 days ago. I don't understand why I only have 4 hands up. 5. We just did this lesson. When we have like fractions, what do we do first? Carla?
We add the numerator.
We add the numerators. Carla, 4 plus 7?
11.
11. What do we do with the denominator? Come on, we just did this lesson. It's the same as subtraction, just the opposite operation. Michaela?
It stays the same.
It stays the same. So class, 4/3 plus 7/3 is?
11/3.
11/3. We cannot leave our answer as an improper fraction. So now, we have to change the improper fraction into a mixed number. How do we do that? What do we do first? Everybody should have it. If not, you got to remember these steps or you got to find it. Zari, what do we do first?
Divide the numerator by the denominator.
We divide the numerator by the denominator. Zari, what's our numerator?
11.
11. What's our, and we divide it by our denominator, which is?
3.
3. Class, 3 goes into 11. how many times?
3 times.
3
3 times.
times. Class, 3 times 3 is?
9.
Class,
9.
11 minus 9 is?
2.
2.
Is there anything to bring down?
No.
No. So now we have this division problem. Where does our whole number come from? Lena,
Our answer.
what part of the answer? Because we have our whole number and our remainder. We can't have 3 remainder 2 as our whole number.
Our whole number.
The whole number. So what is our whole number?
3.
Now, how do we get our numerator? Michaela,
For the remainder.
the remainder. So what's our numerator?
2.
How do we get our denominator? Colin,
Keep the same denominator.
we keep the same denominator, so our denominator is 3. But now we need to check for what? Class?
Simplest form.
Simplest form. 2 and 3 are both Mason? Prime. So if both the numerator and the denominator are prime, what does that mean about the fraction? It's already in simplest form. So, class, 1/3 plus 2/3 equals,
2 and 2/3.
class, 1/3 plus 2/3, 1 and 1/3 plus 2 and 1/3 equals
3 and 2/3.
2 and 3 and
3 and 2/3. Now, I would suggest doing it the way we do it in example 1. That will be quicker, especially for those that are not comfortable with their basic facts, which please take this summer to get comfortable with your basic facts. So, let's go ahead and let's look at the guided practice, and it's going to have us do it using associative property. Okay. Number 1 on the guided practice says find the sum, write in simplest form. We see that the equation is 2 and 3/6 plus 2 and 1/6, and we notice they didn't break down the fractions into unit fractions. So do we have to do that every time? No. But they did break which part down? Mason. There's only 2 parts, the fraction or the whole numbers. Which part did they break down or decompose? Did they break down the fraction into unit fractions? Did they look at this problem. Did they break down the fraction parts into unit fractions? So 3/6 is a unit fraction. No. I'm going to go to somebody who has more confidence. Lena.
It is the whole number.
It's the whole number that they broke down, because we see that the fraction part is the same in our equation as it is in our original problem. But we see that they have put 2 blank lines in front of each fraction. 2 wholes breaks down into how many wholes? Class?
2.
2. So 2 and 3/6 is equivalent to 1 plus 1 plus 3/6. Mason, 2 and 1/6 is equivalent to what? You're filling in the blanks here. The same way we broke down 2 and 3/6. I can't hear you. 1 plus 1/6. equals 1 and 1/6. Is that this number? Mason, how many holes are in 2 holes? 2. So how many 1s do we need to put in our equation to show 2? 2. 1 plus 1. You've got to think. Okay, now we need to use associative property. We are going to group like things. Mason, what goes in our first group? It's just like example 1. We see where they already grouped our fraction parts. So that means which part are we grouping in our first, right here in our blanks? Somebody please help him out. Carla. We're grouping the whole numbers. Mason, we can see they already, look up here please. They already grouped the fractions. We're not going to group the fractions again. They already took the 2 fractions. Are you watching? 3/6, 3/6, 1/6, 1/6, and put them into a group with parentheses. So what is left? Are there any fractions left to put in this group? No. So what's left? The whole numbers or the fractions? The whole numbers is 1 and 3/6. Are they alike? Can we put them in the same group? Are they the same thing? No. 1 is a whole number, 1's a fraction. So what we're going to do is one at a time. We're going to move our whole number from the first part to the group. So what do we put first? 1 plus 1 plus, are we going to add 3/6 here? Are they the same thing? No. So we're going to skip that and add plus. Do we put this 1/6 in the same group with our whole numbers? No. Then we come over here and we add our fraction parts. Is 1 a fraction to put into our fraction group? Is 1 a fraction to put in our group of fractions? Is 3/6 a fraction to put in our group of fractions? Yes. And then we're going to add. Are we going to add 1 to our group of fractions? What about 1 to our group of fractions? What about 1/6 to our group of fractions? Yes. Please pay attention so that you know we're taking whole numbers and we're putting them in a group. And then we're taking fractions and we're putting them in a group. Because that's what you're going to have to do on your independent practice unless you want to do improper fractions like example 2. You're just taking all the whole numbers and putting them into a group. And then taking all the fractions and putting them into a group. Just like example 1. So now, Mason, we need to use the associative property to add these groups. We know we're going to add each group one at a time. So 1 plus 1 plus 1 plus 1 equals 4. 3/6 plus 1/6 equals 4/6. 4 plus 4/6 equals 4 and 4/6. Are we done, Mason? Are you sure? Why are we not done? I can't hear you. We have to put it in simplest form. And how do you know 4/6 is not in simplest form? They're both even numbers. So let's list the factors of 4 and the factors of 6. Mason, would you like to list or match? It's up to you. Please make sure you choose the one that's best for you, not for anybody else. Okay, factors of 4.
1, 2, and 4.
Okay, and factors of 6.
1, 2, 3, and 6.
Common factors. 1 and 2. Greatest common factor. 2. So we're going to divide our numerator and our denominator each by
2.
Now, Mason, are we gonna put our fraction right here?
No.
No, what do we need to do before we simplify our fraction?
Put our whole
We need to move our whole number. So does our whole number change?
number.
No, it does not. We did not see any evidence of our whole number changing in the examples. Our whole number is not changing, just the fraction. Now we can simplify our fraction. 4 divided by 2, Mason?
2,
6 divided by 2.
3,
So that means 2 and 3, 6, plus 2 and 1, 6 equals
4 and 2 thirds.
4 2/3. Make sure that you show all that. Let's go ahead and do numbers 2 and 3 in the independent practice together. Number 2, we're just going to use associative property. Aaron, first we have to break down our first addend into a sum of its whole numbers and its fractions. So 2 and 1/3 looks like what? We write it as an equation. We break it down into a sum of its whole numbers and its unit fractions.
1
1
plus 1
plus 1
plus
plus what?
plus 1 equals
2 would be 1 plus 1 plus 1.
no. 2 would be 1 plus 1.
So we're breaking down 2 and 1/3. I said we're breaking down our first addend, 2 and 1/3, into a sum of its whole numbers and unit fractions. So 1 plus 1 plus 1/3. Now we're going to add our second addend, broken down into a sum of its whole numbers and its fractions. So 1 and 1/3 looks like 1
1 plus 1
plus what?
plus 1 third.
Plus 1/3. But now this is hard because our brain has to jump around and skip things and then go back and remember them. So let's put them in groups now. I'm going to have different people help me. Michaela, now I want to put them in groups. I'm going to have 2 groups. One group is going to have only what? Whole numbers or fractions in it, or both?
Whole number.
Whole numbers. And the other group will have only
Fraction.
fractions in it. So let's go ahead and do our whole number group first. We're going to put parentheses to show that we're grouping things. And we're going to do what? What are we going to put in that group?
1 plus
1 plus
1.
1 plus
1.
1. Are we going to put, do we need anything else?
No.
So we'll close our parentheses. We're still going to put an addition symbol because we're eventually going to add the whole number and the fraction. And now what do we put in our second group? Do we put this?
No.
This?
No.
This?
Yes.
1/3 plus this?
No.
This?
Yes.
1/3. Now we can just add our separate pieces, or separate groups. Smith, the sum of our first group is
3
3, plus the sum of our second group, which is
2 thirds.
2/3. 3 plus 2/3 is what, Zari?
3 2/3 and 3 and 2/3.
3 and 2/3. Zari, is that in simplest form? Or do we need to find simplest form?
It's in simplest form.
It's in simplest form. How do you know?
Because they're both prime numbers.
2 and 3 are both prime numbers. Our numerator and our denominator are both prime. Now, if you struggled or got frustrated because it was hard to fit all this on your page, what should you do for the rest of them? Michaela,
Go to the extra.
go to your separate sheet of paper. You're doing the same exact thing. You're just giving yourself more space. If you look and it's really hard to see number 5 or number 3, what should you do? If your writing is kind of covering up number 5 or going into your space for number 3, what should you do? Zadie?
Use an extra sheet.
Use the extra sheet of paper. It's just to give yourself more space. If you can't really see the answer or it's going into your space for the answer for number 5, you need to use a separate sheet of paper. I don't see anybody using a separate sheet of paper, but I can guarantee there are some people that should probably be using a separate sheet of paper. Number 3, 5 and 1/8, 5 and 1/8 plus 2 and 3/8. Colin, what do we need to do first?
Add our home.
I did that here. Was that first?
No.
What do we do? What did we do in this step that Aaron did first? What is that word that tells us what we did?
We have to decompose.
We have to decompose. So first we need to decompose what? 5 and 1/8 or 2 and 3/8, or should we try to do them all at the same time and confuse ourselves?
First, we should do 5 and 1/8.
So let's decompose 5 and 1/8. What does 5 and 1/8 look like decomposed into a sum of its whole numbers and its fraction?
1
1
plus 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 1.
plus 1. Is that right? How many ones is that?
6.
6. And do we have anything that shows the fraction part?
No.
1 plus 1 plus 1 plus 1 plus 1. Wait, 1 plus 1 plus 1 plus 1 plus 1 plus 1 equals 6. Not 5 and 1/8. So how can we fix that?
Erase one of the ones.
Okay? How should we fix it? How do we continue to fix it?
Plus 1/8.
Add 1/8. Now I'm telling you right now, you can leave the fractions as they are. But you do need to decompose the whole numbers. You can leave the fractions as they are. You don't have to break them down into unit fractions, but you do need to break down the whole numbers. So now we have to break down 2 and 3/8. How do we do that, Colin?
Plus 1
Plus 1
plus 1
plus 1
plus 3.
plus 3/8. Okay. Now we've decomposed our mixed numbers. What do we have to do next, Zadie? We have to group. What 2 groups are we going to create? A group of what and a group of what?
A group of whole numbers and a group of fractions.
A group of whole numbers and a group of fractions. Let's put our whole numbers in a group first. This one
Yes.
plus 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 this one
No.
plus this one
Yes.
plus this one.
Yes.
Oops, any others?
No.
So we close our parentheses. And now we're going to add a group of
Fraction.
fractions. This one,
No.
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 this one.
Yes.
1/8 plus this one, this one, this one.
Yes.
3/8. Any others?
No.
So we'll close our parentheses. Okay, now let's add each group. Victoria, what is the sum of this first group?
7.
7 plus, what's the sum of our second group?
4/8.
4/8. 7 plus 4/8 is what, Lena?
7 and 4/8.
7 and 4/8. Do we need to simplify or are we done?
We do not use simplify.
Check it again. How can we tell just by looking at those numbers that we have to simplify?
We do because
Who can help her out? How do we know just by looking at that fraction that we need to simplify? Zadie?
Because they're
Both the numerator and the denominator are even. So now is where you 100% go to your separate sheet of paper. List the factors of 4 and the factors of 8. Lena, would you like to list or match?
I would like to list on the first one and match on the second.
Okay, that's fine. Factors of 4.
1, 2, and 4.
Okay, now we're going to list on 8. That's perfectly fine. If you know one and you can list them, go ahead. But if you need to do the other one, make sure that you do what you need to do to make sure you get the right answer. So, what's the first factor of 8, Lena?
1.
We know that because
1 times 8 equals.
because 1 times 8 equals 8. Is 2 a factor of 8?
Yes.
Yes. How do we know?
Because 2 times 4.
Because 2 times 4 equals 8. Is 3 a factor of 8?
No.
Because 3 times 2 is,
6.
and 3 times 3 is,
9.
and 8 comes between. So 3 cannot be a factor. What about 4?
Yes, because it's already on the page.
Yes, because it's already there. So do we have to keep going? No. What are the common factors of 4 and 8?
1,
1,
2,
2, and 4. What is the greatest common factor?
4.
4. So we're going to divide our numerator and our denominator each by
4.
4. Now, are we just going to put the fraction right here?
No.
No. What do we have to make sure we do before we put our simplified fraction?
We have to put our whole number.
We have to put our whole number, so we're not saying that 7 4 and 4/8 is equivalent to just one little fraction. 4 divided by 4, Lena?
Is 1,
8 divided by 4?
2.
So 5 and 1/8 plus 2 and 3/8 is
7 and 1 half.
7 and 1/2. Okay. It's time to go to art. So what we'll do is this afternoon, I'll give you more time to work on your independent practice. So yes. So once we finish our religion test, you'll have some time, then we'll go tie-dye at 1:30 at the latest. Okay. Hands down unless it is absolutely pressing right now. If it is a question about tie-dyeing or doing math later, it can wait. But if it's a question that you need answered immediately, then keep your hand up. Okay. Leave, let's see, you can put